In section 6.3, we're going to talk about exponential functions again, but we're also going to talk about something new called logarithmic functions. So up to this point, we talked about exponential functions, which look like the following. So exponential functions that we learned about in this chapter look like a base that is some number, and then the exponent is the variable. So something like this, 2 to the x. We can also look at different bases, like a base of, let's say, 1/2 to the x. We can also look at other bases like 3 to the x, e to the x, 10 to the x. These are all bases that we see a lot. So it could be a fractional base that's less than 1, like we were doing with graphing, or something that's bigger than 1. It could be e, it could be 10, it could be anything. But we're also going to discuss something called logarithms now. So let's take a look at what logarithms look like. So logarithms. Logarithms, we'll see a log is a shorthand for logarithm. They'll have a base as well, but it'll be a subscript, means a little small number next to the log. And then we'll have whatever is going to get plugged into your log next to it. That will be a big number. It will be not part of the subscript. So this is read as log base 2 of x. Just another one that would match up with the 1/2 as a base would be a log base of 1/2. Again, we can still plug in x's. Another example would be, let's say, log base 3 of x. Now, log base e of x, that got used a lot. So I think that people got tired of writing that. So they shortened the hand on that and stopped using log base e and started using what's called natural log of x, which I know it says natural log is what it's called, but it's written out as L first for the log, and then the N actually comes second for natural log. So if you see natural log ever, even though you don't see a base, a little subscript, it's always understood that if you see a natural log, it's automatically a base of E. There's one other special log, and that's a log base 10. And again, it gets used a lot, so I think people kind of got tired of writing this out. So they started writing out just a regular log with an x. So what this means is if you ever see an logx with no base, it's understood that if you don't see a base on an log, it's automatically a 10. Kind of like whenever you see a root and you don't see a number, it's automatically a square root. If you see an log without a base, it's a base 10. If you see an ln without a base, it's always a base e. Now the question becomes, why am I talking about logarithms and exponentials at the same time? Well, here's the punchline. They are inverses of one another as long as their bases match up. So what is going to undo or be the opposite of a 2 to the x is a log base 2. And in reverse, what's going to be the inverse or opposite of a log base 2 is going to be an exponential base 2. What's going to be the inverse or opposite of a exponential base 1/2 is a log base 1/2. What's going to be the opposite or inverse of a log base 1/2 is an exponential base 1/2. Keep on going. The same ideas are going to apply. What's going to be the inverse or opposite of an e to the x is we don't use log base e, we use natural log. What's going to be the inverse or opposite of a natural log will be the e to the x. What's going to be the inverse or opposite of the exponential base 10 would be, we don't use log base 10. We use just a regular log. So that will be its inverse. And what's the inverse of the log, which is, again, automatically a base 10, will be a exponential base 10. So these are all inverses as long as the bases match up. And remember, inverses undo one another. Another way of remembering inverses is, remember, you swap your x's and your y's. So that's a quick reminder about inverses. How do you find inverses? Remember, for inverses, you swap x's. You swap x's and y's. That's how you find your inverses. But notice with these, when you're finding your inverses, whether it's an inverse of a log is an exponential or the inverse of the exponential is a log, notice that the base stays the same. That's very important. So let's play around with this idea of how the exponentials and the logarithms relate because they are inverses.